My name is Peter Young, and I'm president of Societe de Chimie Industrielle, and also I'm the head of the programs committee, of which this webcast is part of that program. I just want to take a minute just to give some welcoming comments before I turn it over to Federico Manila, who arranged today's speaker, who will introduce Raphael, and then Raphael will give the presentation. I do want to just say that everyone really knows how to use Zoom, I assume, but in terms of the questions at the end, the best way to send a question is to use the chat function that I'm sure all of you are quite familiar with. My sense is that most of you know Societe quite well, but for the few that don't, it is a 102-year-old nonprofit that founded in 1918 with a couple of missions. One is to help educate people in the industry or related to the industry on issues that are happening. And obviously this is an example of that. And by the way, Societe de Chimie Industrielle, chimie in French covers both life sciences and chemicals, and that's what we cover both. And we also give scholarships to many, many students studying chemistry or biotech. We have mentor programs, and we also have the very well-known International Palladium Medal Award dinner, usually every 2 years, to honor someone who has really contributed a lot to the industry. I'm very proud to be involved. I've been on the board for many years, and we have pivoted from the challenges of the pandemic. And last year, we actually had 20 events through the year, which is more than we normally do. And thus far this year, we're on track for about 25 events. Before I turn this over to Federico, I just want to mention to you the upcoming events. First of all, on September 2nd, we're going to have two prominent members of the API pharmaceutical intermediates industry, who one from SK Biopharma and one from a company that's a heavy producer of technology for the industry. And they're going to talk about what's happening, but particularly how the supply chain problems are forcing changes in terms of how people get raw materials and how they get APIs, et cetera. That's September 2nd. Then on September 15th, we're privileged to have Dr. Kevin Swift, who is the chief economist of the American Chemistry Council. He's going to talk about the chemical industry economic outlook. Then September 29th, we're going to have the two editors of the two prominent chemical industry business periodicals, Rob Westerfeld of Chemical Week and Joe Chang of ICIS Chemical Business. And we're going to talk about what's happening with ESG, which, as you all know, is a hot topic, environmental, social, and governance. They're going to talk about what the challenges are for the chemical industry. Then October 29th, we are going to have the Societe Career Fair and Forum for Life Sciences. As we had a very successful one covering the chemical industry, where we matched 150 students with 10 companies. We had one in chemicals at the end of March, and we're going to do the same thing for life sciences. And hopefully many of your companies would like to participate, because we had some fabulous students from leading schools around the country. And then October 20th, we're going to have the CEO of Vigon, Steve Summers, who is going to talk about nurturing growth and entrepreneurism. And Vigon is a very successful ag chem related company, which he actually started. And he's going to talk about how they managed to grow that company, but also what's happening in the ag chem side. So that's just the events between now and the end of October. But I hope you'll agree that we have some very interesting and varied topics, and we hope that many of you will participate. So with that, I'd like to turn it over to Federico Manila. Many of you know him. He's been a board member for many years, but he also is head of chemicals for Rothschild and has been a veteran in the chemical industry for many, many years. So Federico, let me turn it over to you.
Thank you, Peter, for this introduction to Societe and to our program. Today, I'm very, very happy to introduce Raphael Crawford, who is the president catalyst for Albemarle Corporation. I've known him for quite some time and admired his career. He started in the space working for Roman Haas in 2003, progressing in different capacities in what after the merger became Dow, and run the global marketing and business development for the coating material business for Dow, and then joined Albemarle and in 2012, and was really focused on catalyst at the time, and then broadened his portfolio to eventually running the Roman Specialty Business Unit, and is now president of the catalyst unit. What is important and interesting for us is the title of this webinar: Challenges and Opportunities in the Catalyst Business. It's a very dynamic space with a lot of new technology, and really we look forward to a conversation with Raphael, where he's gonna share with us his thought about the opportunities and the challenges facing the space. So we are delighted to have him on available for us with the presentation, and leave the floor to him.
Hey, thanks, Federico. This is Raphael Crawford. I appreciate the time to be with you today, and I appreciate the invitation. And Peter, that sounds like a great agenda that you have going forward for meetings and interesting topics. So I'm certainly going to tune into many of those. Hey, I want to welcome the participants. You know, just looking through the list, I see people that I know. So it's great to have new people that I don't know. I see David Begleiter, Hannah Rogers, who helped me put this presentation together, James Romano, Rick Clare. So great to see folks that I know, and it's great to be part of this society. I'm going to make a presentation. I'm going to do my best in Zoom, and I'm going to share so you can see it. So let me get that in slideshow mode, if I can. So, you know, what I'm going to cover today is really about, I think it's probably more opportunities than it is the challenges of catalysis. I'll talk a little bit about what Albemarle Corporation is, if you're not familiar with Albemarle, and then a little bit what the catalyst business does in Albemarle, but I think more so about the opportunities that exist in the new energy space. Catalysis is widely used in chemical processes, in pharmaceutical processes, sort of it's ubiquitous. In areas of use that relate to refining, which is a big piece of the business I have, those are areas that are certainly changing. The dynamics of refining are changing, and necessitates that catalyst applications move into new areas of opportunity as it relates to the new energy economy. And that's what I want to talk to you about today. And I'm happy to answer any questions that y'all have. If you want to put it in the chat in Zoom, that's probably the best way to do it. And then we'll certainly get to that. But it's great to see old friends and make new friends, and happy to be here today. So let me just tell you quickly about what Albemarle is. Albemarle Corporation is, you know, roughly $20 billion market cap company in specialty materials space with 3 business lines. I think that Albemarle is probably most famously known for our lithium business. Our lithium business is one that we acquired a company called Rockwood Holdings back in 2015. It's very much geared towards satisfying the needs of battery materials going forward, as to fuel the growth in EVs. And Albemarle is the largest player in the lithium space, sort of the best resources and the biggest player, and a great advantage that the company has. And that's a business we acquired and have fostered since 2015. We've been in the bromine business for longer than that. If you go back historically, our bromine business is about 50 years old through various owners. Our bromine business, again, one of the best businesses among the bromine industry. A lot of the bromine business goes into flame retardants. So those are chemical compounds that are mixed in with polymers, such that when those polymers catch on fire, it retards the flammability of that, which gives heightened safety for electronics in automotive or servers or anywhere where you would find a flammable risk as relates to polymers. Also myriad applications in oil drilling, in bromobutyl rubber, water treatment. The catalyst business is the business that I have the privilege of running. This business that we have is very much geared towards helping refiners make more money. So it helps them do things to maximize on yield, to remove contaminants, very much oriented toward helping the refining community, those making gasoline, diesel, other fuels, make the most out of their inputs that they get into maximizing outputs. That's the business we have. It's a business that has a leadership position, but that being said, the whole refining industry has come under pressure from the energy transformation, from the pandemic. I mean, I don't know about you, I'm not sitting in an office right now. I'm like at a conference room that's away from my office because I had to find a place with decent Wi-Fi, but I'm nowhere near my office. And I think like that's an indicative of what the future looks like. Maybe not all the time, but it is the future that there will be more work from home. And I think everybody sees that, and that creates like additional pressure on the industry. And I think if you couple that with, again, Peter had talked about topics that Rob Westerfeld and others would talk about on ESG, certainly the drive towards renewables, clean energy, all of that, creates an additional challenge and opportunity for the refiners around the world. And we as a business are looking at what are the chemistries that satisfy that need. And that's a little bit of what I want to talk to you about today. I do want to call something out, and I do want to give a shout out to Anna Rogers. Anna Rogers, I think she's listening in. She is in our communications group, also an experienced technical writer. I guarantee you that nobody has ever seen a presentation with more citations than the one you're going to see today. Practically every bullet point has a citation. So Anna, great job in like doing a good job with citations. Also, we're going to post this presentation online. Certainly, you have access to like look at it, and in the back are all the references. So if you want to learn more about catalysis or clean energy or Albemarle, you can find all the references in the back, and that'll give you a chance to do further research. So just real quick on catalysis, like what is a catalyst? So a catalyst is a substance that increases the rate of a reaction without being consumed. So what that effectively means is it's something that you put into the process of the reaction that helps facilitate the reaction, but does it with lower activation energy. So a lot of the things that we do in chemistry, you can do without a catalyst, but it just requires tremendous heat, pressure, time, temperature, like all of that has to go in if you're not going to do it via a catalytic route. And that's why you find that in a lot of the chemical processes that we have, a catalyst is present. I mean, it's like omnipresent. Maybe not everything is using a catalyst, but it's so ubiquitously used because it's changing the reaction properties such that it's happening so much more quickly and efficiently than if you didn't have a catalyst at all. And I think like the principle of it not being consumed means that while it's driving the reaction, it doesn't actually end up as chemically as part of the final product. Now, in some cases, folks have asked me like, well, in some like polymerization properties, the catalyst actually gets polymerized into the plastic. Like, so, yeah, and that's true, but the catalyst itself has not been consumed by the reaction. It's just sort of like present in the plastic. In itself, it's still there. And I think that's sort of a necessary piece of the definition of a catalyst. And again, you're going to find it in lots of different applications in refining, chemicals, pharmaceuticals, plastics production. It's ever present. So when we talk about oil refining, this is really taking petroleum, which is a mixture of hydrocarbons, often referred to as crude, and then breaking it down into fractions. and those become like usable fractions for other things. So for example, if you look at the diagram on the right, it's really giving you a sense that like when you bring crude oil into a refinery, sort of the first step is usually distillation. And there's a distillation column, and that's going to be the first step, which through heat and pressure, it's going to start to fractionate what's in that oil into usable components. And you can see at the boiling point at which those arise. So, kerosene and jet fuel, you'd be familiar with. Distillate is usually what the term used for diesel and heating oil. Naphtha and gasoline within that range is sort of like get blended into the gasoline that you use for your car. This is sort of like what happens in oil refining and sort of the step one. So if you go back before catalysts were used, this is like about where it ended. When you pivot to using catalysts in refining, what you're doing is essentially fine-tuning that further fractionation of what you have. So after being separated in the distillation column, we further process those through catalytic processes. So, and there's two ways to get at that, right? And it's often called cracking. And it means taking long hydrocarbons and breaking it into smaller fractions. Catalytic cracking uses a catalyst to speed up the reaction. You can also do this thermally, which means by heat and pressure, but that's a slower process and it's more energy intensive. So catalytic cracking is the more common process that happens in industry to get to smaller and smaller chains, which become more and more usable to end markets that need chemicals or fuels. And within the cracking world, there's two different kinds of cracking catalysts in an oil refinery. There's fluid catalytic cracking and hydrocracking. FCC cracks heavy oils into heavy gas oils, like vacuum gas oils, what comes out of the distillation column, into gasoline, while hydrocracking cracks heavy oil into diesel and kerosene. Now, Freundenreich has it right, but one additional piece on this is that when you do cracking of any kind, you get a mixture coming out of that. You don't just like crack into gasoline. You get gasoline and you get diesel and you get kerosene and all the other fractions, olefins and things that come off of that. Just the process you use tends to give you more of one than another. So that's where FCC tends to crack more into gasoline, where hydrocracking cracks more into diesel kerosene in volume percentage. So just to be clear. In the FCC process, again, we're talking about like the way it's done today, particles, and they're fluidized, and they're put into the feedstock, and that feed is then vaporized and cracked. And hydrocracking, which is with hydrocracking catalysts, serve really two fronts. It is about cracking, but it also has a process of removing sulfur and nitrogen through the process of injecting the hydrogen into the unit. Catalysts can also be used to do other things in a petroleum refining unit. And again, those in industry know that catalysts are omnipresent. I mean, they're everywhere. They're used for so many different things. We're specifically talking about refining. Catalytic reforming is used to generate aromatics and components for finished gasoline. Hydrotreating is largely used to remove sulfur and other contaminants. We talk about hydrotreating a little bit later as to like what can hydrotreating do for the new energy economy? Like where does that fit into the world of biofuels or into pyrolysis oil or other downstream applications? Alkylation is used to make alkylate, which is a blending component for gasoline, and isomerization is used to convert light naphtha to higher value, higher octane gasoline. So overall, refiners are using catalysts, an array of catalysts, to crack the oil coming in, crack the vacuum gas oil coming out of the distillation column, to crack resid. They're also using it to reduce sulfur, and then a myriad other applications within the refinery. With that, one of the big things that we need to be working towards is, so how do we address where the economy is headed, where, not just the economy, like where the world is headed in terms of the need for lower greenhouse gas emissions that result from burning fossil fuels? How can refiners play a role in that next generation of energy, and what could catalyst suppliers like us, what could scientists in industry do? And that's why we're speaking to all of you. So I wanted to give you a view on what that could look like. So let's talk about like decarbonization of fuels. It's sort of widely known that the economy is moving toward net zero carbon, really sort of like moving towards like cleaner fuel stocks, lower greenhouse gas emissions from transportation fuels. And it's a collective effort. It's not just suppliers like Albemarle, it's the refiners themselves. It's a group effort to get to a lower carbon footprint from the use of transportation fuels. You know, one of those solutions is biofuel. Biofuel is made from biomass materials, biomaterials, generally regarded as a lower carbon impact fuel than traditional petroleum-based fuels for two reasons. One is while it does release CO2, it's often less. So it can be less than what traditional fuels. And second, in order to like produce biofuels, you actually have to be planting things to be able to do that. So like the organized planting of bio-based materials that can go into a fuel creates plants that also absorb carbon. So sort of like the net effect of biofuels is the fuel itself, but also how you produce that fuel and where the feedstock comes from. And the renewable nature of biofuels means that if done right, there should be a limitless supply, maybe not limitless, but like an eternal supply of fuel coming from bio-based materials that you can get if you're planting, farming in the right way, and using it to produce fuels. Hydrogenated vegetable oils and biofuels are expected to grow at 30% CAGR through 2025. So it's certainly going to be like growing at a faster clip than traditional fuels and creates a tremendous opportunity. And through the 2030s, it's projected from EIA that about 10 to 15% of the diesel market will be biodiesel. So again, growing in its share of use in the market, which is good for, gives an opportunity for refiners to reinvent some of what they do in the direction of a more sustainable transportation fuel mix. So like how do catalysts play into biofuels? I mean, first of all, there's a few different ways. One of them is like in the production of the biofuel themselves. So there's a catalyst that's used in the conversion of like multiple catalysts. So if I say a catalyst, I mean that like there's families of catalysts that work towards producing renewable diesel, biodiesel. There's a lot of work being done on sustainable aviation fuels. In traditional biodiesel is fatty acid methyl esters that's used with, there's multiple catalysts used for that, but certainly there's like, it's the original biofuel. And then certainly like other catalytic processes to be able to make biofuels. The piece that's like very interesting for a business like Albemarle, but also for the industry, is catalytic hydrotreating of renewable fuels. And what I mean by that is that if you consider where some of the biomaterial comes from, whether it be from vegetable matter or used cooking oil or other like materials, the challenge is like it's not always clean, which means that like when you're using that material and you're trying to crack that material or catalyze a biofuel, it's a challenge. And it's a challenge because the purity profile coming out may not be to the same standard as traditional petroleum-based fuels, just given the history of producing petroleum-based fuels. So there's a lot of cleanup that has to happen on the front end and on the back end of making biofuels. Catalytic hydrotreating is that's emerging as the mechanism to clean up biofeedstock and biofuel coming out of a refining process used to make renewable diesel or biodiesel or sustainable aviation fuels. Right now, like hydrotreating is used widely in refineries. Those of you who know refining know that hydrotreating is used to remove sulfur, it's used to remove other contaminants, it's used before an FCC unit, it's used on the back end to clean up fuel, It's the injection of hydrogen into a process to step out the contaminants within that fuel stream. So hydrotreating of biofuels is a tremendous opportunity for the industry that is biofuels. Again, you're dealing with biological material. It's not uniform. It certainly relates to, creates a series of challenges, again, as it relates to impurities within the material, and dealing with that can create yield losses. So if you're not using an effective method to clean up your biofuels, it often leads to a yield loss. Specifically, there are a series of reactions that produce CO2 and carbon monoxide, which become very detrimental to product yield. So in these cases, again, you have to use a catalytic process to trap some of those materials. The HDM process is a catalytic process that's widely known and emerging in this space, which is specifically designed to remove phosphorus, alkaline metals, to ensure that the unit runs at maximum efficiency. Albemarle participates in this space, as do others. I would expect that as like the market grows in biofuels, you will start to see more and more advanced catalytic hydro demetallization processes to be able to clean up that space. You know, the interesting thing, if you think back, and I guess you probably can consider this in like almost any chemical process where you're mixing like feedstocks together. At small scale, you can blend anything, right? If you have a bio feedstock that has some contaminant profile, but you're only blending it into your normal feedstock at 1% or 2%, it's probably okay. Your current system can handle some amount of tolerance of contaminants within what you're doing. If you go much beyond some nominal amount, it then becomes, that's where it becomes an issue. That's where it becomes an issue for your other catalytic processes, for your downstream units. That's when you need to start thinking about pre-treating your feedstock with advanced catalytic processes to go and do that. You can only blend so much to like dilute out the metals and of foreign material that you don't want there. So I'm going to pivot a little bit towards petrochemicals. And again, this is about like the future of like where refining is going to go. And it's pretty well known. If you look at the chart, you can sort of, and these are McKinsey estimates, you can sort of get a sense for like peak oil is somewhere in the 2030 range, right? Or it looks like peak oil demand is like, by their estimate is 2029. I've seen IHS estimates that go like a little bit further out, but let's just call it like 2030 in that range. So I think we have to like be mindful of like when you're a refiner or you're somebody supplying a refiner, what can you do to help them build a sustainable business for the long term? Because what you will see is you're seeing a demand decrease in the future for oil applications into fuel, but what will be growing? And I think the piece that's going to continue to grow is on the petrochemical side. So this is really about shifting away from transportation fuels toward petrochemical applications. You know, frankly, like almost all of the new refineries, well, maybe all, I don't know, I was going to say almost all just in case I'm off by one, but I would say the vast majority of like new refineries being built, first of all, they're all being built somewhere east of Suez, and almost, if not all of those refineries have a downstream chemicals unit associated with it, meaning that they're not just there to make fuel. They want to supply a local demand for fuel, but they certainly want to be able to make plastics as well. So the chemicals that you're able to get off of a refinery are olefins. Olefins are often used within the refinery they're used to create, like they're used downstream to boost the oxygen, the octane content of fuel. So they're like used within the refinery back into fuel, but more and more they're being used in a downstream polypropylene unit. And that sort of is the downstream chemicals component you find most often. Aromatics. So BTX aromatics more specifically are in high demand. often into nylon applications, other specialty applications. This is a growing demand. And then synthetic gas applications. These are all things that are like downstream of a refinery that have more forward growth potential than transportation fuels themselves. And catalysts play a role in developing that market going forward. Today, petrochemicals are primarily produced using LNG and crude oil. These are the typical feedstocks. In order to produce petrochemicals, you're going to do this with cracking your feedstock at either high temperature and pressure or lower temperature and pressure using a catalyst. So that's like the catalytic theme. Catalysts enable you to do things at lower temperature and pressure. Again, that saves money in terms of energy usage, natural gas usage, and it also happens quicker. High performance catalysts help you to get this all done at lower temperature, lower pressure, and faster. So let's talk a little bit about like how chemicals production is going to work going forward. Petrochemical plants and oil refineries, again, they process hydrocarbons. They're making a whole slate of products. You can't make just one thing out of a refinery. You're going to make a slate of fuels, olefins, chemicals, oils, all of that will come out of a refinery. The refineries of the future will be those ones that, as I said, have a downstream chemicals component to them. Older refineries are also able to retrofit, but it's tougher. I mean, it just requires more capital. It's certainly possible, and there's certainly options to go out and do some different things with existing refineries. But it's a more capital intensive process than the new refinery builds, which is already build that integration into what they're doing. And, when we think about the target petrochemical and the petrochemical feedstocks production, a lot of it is geared towards olefins, naphtha production, and also propylene as the most prominent olefin that folks are looking for. In fact, Albemarle has a lot of catalysts that are specifically designed for propylene maximization. It happens to be like our area of super strength as a company. That's like where we focus our attention because we know that the demand is there downstream for olefins production, specifically on polypropylene applications. So what role does catalyst play in this shift? So again, we've talked about a couple of shifts. I'm going to share three with you. One of them is the shift towards different kinds of fuel out of a refinery using a catalytic process. Number two is the role of catalysts in chemicals application. And we're going to talk about recycled plastic in the next one, which again, I'm very excited about the potential for that. This one is, again, we're talking about propylene maximization from the fluid catalytic cracking unit. Typically, the output of propylene from a unit is around 5%. That's sort of like the normal yield on propylene from a refiner's FCC unit. That FCC unit is a critical unit at the center of the operation. Lots of refiners are looking to push that number up. They're looking to get higher and higher yields. There's actually a catalytic additive called ZSM5. It's a zeolite crystal, which allows for that like higher activity, and it increases the rate of the chemical of the reaction to drive higher yields. So the amount of additive you add, the effectiveness of that additive is going to drive up the yields. There's certainly things that inhibit that. So there's processes within the refinery that could be at odds with that. It's usually, it's a zero-sum game to some extent. Like as you're trying to push one thing up, another thing's coming down, and sort of there's competing reactions within the refinery. So it's a careful balance of how catalyst suppliers, technology licensors, and refiners work together to drive the maximum yield of chemicals as they're trying to increase that balance of chemicals output versus fuel. The highest yield that we have seen in our business, and we consider it a record. I can't vouch for like, well, maybe there's an example we're not unaware of, but we work with all major refiners, is a 12% yield of propylene out of a refinery, and that was demonstrated in 2019. in Asia. So certainly a lot of opportunity within refining to use catalysts in a different way to tailor the yields to higher propylene, higher chemicals output within the refinery. So let me pivot to a final opportunity, and this is around waste plastic. We're all very aware that the world has an issue with waste plastic. I know it's heavy on the minds of consumers, on brand owners who have plastic packaging, and all the way back in the value chain. And it's a critical priority for petrochemical producers to be part of the solution to get to lower plastic waste in our oceans, in our environment. There's several different ways to recycle plastic. The one I'm going to talk about today is pyrolysis. Pyrolysis is a process, it's a high temperature, high pressure process to convert. It was originally used with biomass, now used with waste plastic, to turn plastic waste into a synthetic oil that can be used as refined into fuels, or in many cases blended back into the feedstock to make, can't call it virgin plastic, but as a component into new plastic production. Catalytic processes play a huge role in pyrolysis. They're there to drive the reaction, to get the pyrolysis reaction complete. As I said, it's done under extreme pressure and temperature conditions. So to the extent that that can be reduced, it opens up the world of how we can do pyrolysis applications with plastic, which can make a huge dent in the world's challenge on plastic recycling. And again, if I come back to pyrolysis oil, again, I'm very excited about this. I'm excited about it for our company, and I'm excited about, quite frankly, for the industry and for Mother Earth, which is, the pyrolysis oil. Again, you can feed it back into a refinery, or you can use it in a petrochemical plant. It's very small in application today. I mean, just the amount that's actually produced, it doesn't hardly make a dent in the feedstock needs for making plastic or going into a refinery. But it's projected to grow at significant rates over the next 10 years, such that it'll be a meaningful piece. As I said, historically, if you have small amounts of feedstock which are non-traditional, and you want to put them into a petrochemical plant to use them, or you want to use them in refining, there's a certain amount of tolerance that exists within those units, such that small amounts are fine. Once you get to scale, it becomes a much different challenge, because again, consider what pyrolysis oil, it's like junk plastic turned into an oil. It's going to have all kinds of contaminants for whatever was in that plastic to begin with. Some of that gets cleaned up, in the making of the oil, but again, it's going to be dirtier than a lot of the other pure petrochemical feedstock that you would have traditionally used. The opportunity for hydrotreating is tremendous for future growth in this space, meaning hydrotreating catalyst for using hydrogen and a catalyst to clean up that feedstock for the future, which makes it much more usable into traditional petrochemical plants and refineries. And again, those catalytic processes are something that my team is working on. The industry is thinking about. Tremendous opportunity to use a catalyst business that was geared exclusively toward using petrochemical feedstocks, or toward petroleum feedstocks, into using, treating feedstocks, processing feedstocks that are sort of associated with the transition in our energy economy, which is very exciting. So again, I just want to wrap it up. I mean, I could talk about this all day, but I want to give you guys time for questions. The world is moving toward net zero carbon. So we're going to be challenged in the traditional model of traditional fossil fuels over the coming decades. And it's a challenge for refiners and suppliers to refiners. But there's tremendous opportunity. That opportunity is in increasing petrochemical demand. So for chemicals and plastics, will continue to grow as the middle class grows around the world. In recycling applications, catalysis is going to play a major role in all of this. There won't be new exciting applications in the green energy space that don't involve catalysis to some extent, whether it be in hydrogen, biofuels, and recycling and circularity. So catalysis plays a tremendous role in all this. So again, I am grateful. I want to say again, I am very grateful to have the opportunity for Federico to request that I participate in this today. I hope y'all learned something. Anna Rogers, great job helping me with this presentation. Very grateful. You did a great job. And with that, Federico, I'm happy to answer any questions that I can.
Sure. I have one question, and I'm encouraging everybody else to come up with others. This is from Stephen Denny. The question is, can you talk about catalyst development for the reaction of biodiesel byproducts, for example, HDO, glycerol, and the role that has in market growth? The question here is, can you specifically discuss upgrading byproducts to higher value products?
Well, Stephen, I don't know that I'm the right person to answer that question for you. That's a fantastic question. I mean, I'm very aware that when you're working on catalytic processes in biofuels, you're always going to have some byproduct material that affects the total yield. And therefore, there's ongoing development to maximize on yields of biofuels, as well as recycle components coming off that may not appear to be usable at, on the first pass. But I'm not the right person, Stephen, to give you the best technical explanation on that. But certainly, it's a great question. If there's a way to follow up with you after, I would be happy to make that connection. For anybody that's on this call, my email address is pretty easy. It's raphael.crawford@albemarle.com. If you have any questions or you have anything you want to talk about as it relates to catalysis, if I can't answer that question, I can assure you that I know folks who can.
Another question is from Sean regarding the production of chemicals from refinery. What is the outlook for C4 olefins? It was a hot topic a few years ago.
Yeah, so C4 is the the demand for C4 often relates to, from a refinery, is most widely used back into the refinery for production of gasoline blending components. It's used to enhance the octane component of the gasoline. So when refineries are running at full rates, and for example, in the United States, you go back to 2019 or 2018, tremendous export market in refining to Latin America and elsewhere. Tremendous demand for C4s because they needed that for the oxygen, the octane component of the gasoline. I think it cycles with gasoline demand. There certainly is C4 demand in other applications, but I think this biggest demand is still within the refinery for their own processes. And again, I know folks in the C4 industry that are outside of refineries. And again, when the refineries are running really well and really hard, they're certainly seeing that demand increase for additional C4s into that process.
Another question is about refiners repurposing assets to make HVO. Which assets are these, or more simply, what capabilities or finished products is a refinery giving up to do this?
Well, I mean, I think in the biggest, if we just talk about biofuels in general, I mean, I've seen whole refineries convert. So, and I'll just talk about biofuels in general. I mean, if you look at Phillips 66 Rodeo in California, they're certainly converting the whole refinery into making biofuels. Now, there is some incentive to go and do that for them, but they're government, local incentives to go and do that. But they're certainly making a big play in their portfolio towards that application. Valero is in partnership to go and make green diesel, but it's a new asset. It's tough to make that conversion of a part of a refinery into a HVO application. You're usually looking at a new build of some sort, or a conversion of an existing refinery. I think there's an example from Total that's also announced recently that they were heading in the direction of converting a whole refinery into biofuel applications. On a unit, within a unit, it's much tougher. What you would see within the unit operations of a refinery, which is more common, is not converting into biofuel production as much as the use of bio-based feedstock. So some bio-based feedstock that can be cracked along with petroleum in some fraction. So not all bio-based feedstock, but blending in bio-based feedstock into the refinery and cracking that along with their petroleum. They're making traditional fuels, but again, using a renewable source. And particularly in Europe, we hear of that more and more. And again, that's different. I mean, essentially, when you're making fuels or you're making anything, anytime you start changing the feedstock, you need to like tailor the catalyst to be able to do that. So, you know, we're not the only catalyst provider in FCC catalyst, but we're a large provider. We certainly get lots of questions. We do a lot of work with our customers, a lot in Europe. And like, how do we tailor our catalyst to adjust for the fact that they're going to blend in a certain fraction of biofeedstock into the refinery?
Thank you very much. Another aspect of this is from a question from Irving Turling. You talked about catalytic pyrolysis of waste plastics. What, in your view, needs to happen for this pathway to become viable and mainstream?
Yeah, it's a great question. It's a lot of it is like the being able to handle this at scale. I mean, I think that like waste plastic has its own challenge of like being able to collect enough feedstock to be able to do this in a way at scale so that you're getting enough product such that the economics work out. There's tremendous energy and activity around this. And, you know, as far as the opportunity for pyrolysis oil from waste plastics is probably like I'm not like an expert on this, but from like what we've studied, it's like among the most viable routes for dealing with the plastics waste issue. You just have to be able to collect enough plastic, process it at scale, and then be able to clean it up, as I said, most likely with hydrotreating, to be able to get it back into a petrochemical plant or into a refinery. But almost with anything going on in like the new energy space, when it starts to happen at scale, the economics start to come into favorable territory, which enable you really to build momentum. And I'm very excited for this. Again, as I said, I think it's a great business opportunity for the industry. Let's just think it's great for like solving the challenge as it relates to waste plastic, but we got to get scale. And that's like essentially everything green energy has to be scale driven to make the economics work.
There is a general question about how does the business that you're running fit with the other segments of Albemarle? So it's more specific to your company, and what are the synergies or the opportunities there?
Yeah, you know, it's interesting. Albemarle is really a company that's moving itself more and more in the direction of the new energy economy. And I've been in Albemarle for almost 10 years. So I look back on time and like, well, what was it like 10 years ago? I didn't feel like it was that way. It was a great company doing great things, but really we're like moving very quickly in the direction of the new energy economy. At the very forefront of that is our lithium business. So we have a lithium business, which, as I said up front, is the premier lithium provider in the industry, the biggest with the best resources. So like that's really moving forward. And I think like, quite frankly, like historically, the catalyst business was maybe the other end of the spectrum. I mean, it's very much in alignment with producing transportation fuels from petroleum. What unifies us is like the push towards the future. And really the work that I do with my business, which is not just because I'm trying to align my business with the message of Albemarle. It's the right thing to do to pivot this business toward some of the new applications that I described today, such that it really is better aligned with like where the new energy economy is going. Doesn't mean giving up on the refiners that we have today as customers, but certainly preferentially looking for opportunities in new space, which aligns with that overall thrust of Albemarle in that direction.
Given the various cross currents that you have described and the different dynamics, what do you think is the long-term growth rate of your business? If you had to pick, or generally, you want to talk about it.
Yeah, no, it's a good question. I think it all depends. I mean, we're going to see the business again in refining, and those who supply refining have had a recovery. We'll see a recovery as everybody gets back on the road. I think it will pick back up. But again, I think it's a business that ultimately grows at the rate of transportation fuels. Now, but some of that's going to be a different mix of transportation fuels. So it's going to be influenced by how much we can participate in HVO and those applications. And we're starting to see a greater and greater influence from petrochemicals on our business. So I don't know, it's a business that in the long term grows somewhere in the single digits, which is a healthy growth rate for a business like this. But it's Federico, I don't know who asked the question, but it's certainly something that you got to go through. We've probably seen the worst of the pandemic, and now we've come out of it. So the business is going to grow pretty quickly over the next couple of years as we recover from this, and then as we align ourselves more and more to new energy applications. I think that should be a tailwind for the business.
And so you think high single digits, just to
I think at some point. I mean, I think it's going to be better than that over the next couple of years.
Right.
But I think beyond that,
a secular growth or whatever.
Yeah, I think beyond that, it's probably low single digits in growth going forward. Again, there's a headwind as it relates to traditional fuels, which is something that we participate in, but a tailwind on chemicals applications and new transportation fuels initiatives. And again, we're pretty excited about the opportunity in pyrolysis. We have other opportunities in circularity as it relates to catalysts and metals. So some interesting things in our business.
Given this is your own opinion, the oil and gas industry, do you think that they will be able to develop technologies that will have, let's call it, a similar total carbon footprint as the other alternative energy sources? Because they're also, there's a dynamic here between the different components.
I think that the refining industry, from what I know, that they are extremely resilient. They have tremendous operating discipline, and they're very resilient. And many refiners see the change coming and are making that shift. Again, I'm not here to pick which refiners, but I gave you one example already on Phillips 66 and their Rodeo refinery. I look at Phillips 66 in many ways as being out front in looking for those applications. Certainly ExxonMobil is looking for new applications, ways to improve their carbon footprint. I think that the world is going to change, and I think it's a necessity. There probably will be fewer refiners in the, I don't know when, but I think there'll be some consolidation of refineries such that some of the ones that are not willing to change will probably go away. And those that are out front and willing to change, which many are, they'll survive and they'll thrive, and they'll align to sort of the new energy footprint. Though, Federico, I would have to say that, traditional gasoline is not going away. I mean, it's not going away. I don't know, I can't say never, but it's going to be decades and decades and decades. I mean, it's still going to be around. There's still an existing infrastructure. There's existing fleet of cars. It'll be there. It just will start to decline relative to the increase in renewable fuels, hydrogen applications, EVs. I think all of that creates a headwind, but it'll still be there. And those who can adapt and also operate with the greatest amount of discipline are going to continue to survive among the refiners.
John Roberts has a very specific question. The addition of petrochemicals to the Motiva refinery was one of the largest conversions. The project was just suspended. Is that just an example of how hard it is to convert existing refineries to chemicals? Or maybe there was a specific nuance to that project suspension?
Which project was it, Federico?
Motiva.
Motiva project. Yeah, I saw that also. I think that John, and I know John, so I think that that's specific to that piece. I mean, there's still a tremendous push ahead on petrochemical applications around the world. I don't know the specifics of that, why that project stopped, but I think it's an anomaly. I don't think it's indicative of what's going on around the world. I mean, again, large projects are starting up, moving forward elsewhere, and they all have that downstream unit, and I don't see any wavering on that. We have large customer in UAE, again, continually looking for opportunities to push up yields on propylene and otherwise, because they just see that like that downstream demand is there. I can't speak specific to that one, John, but I see the trend elsewhere.
Just to remind people, we only have 4 minutes, and Peter is extremely punctual. So just wanted to let everybody know, if you have questions, pass them through. One more is, what is the current economics of biofuel production through the refinery versus traditional route? And how does catalyst play a role in moving these economics?
Yeah, I think that the economics continue to improve for biofuel, but as I said before, it doesn't really go through necessarily the same refinery. It's usually like separate units that are converted or invest in that process, and they find a way to make the economics work. Again, some of it's local. I mean, you could look at the units that are Nesta is a leader in biofuel and among the most profitable at doing it. So again, they're doing it at scale. When done at scale, there's a route to profitability. In some cases, it requires government support, at least to get going for your initial economics, but long-term, these have a positive payback. And I think that's why you see the investment in that space.
Another question is, what's going on in China with respect to these trends? Like we're talking about a lot of the East, but talking about new trends and new technologies out there. What do you think?
Yeah, so I think in China, there's similar trends. There's certainly like more demand. If I get like specific, I see the question from John. In China, there's certainly a lot of interest in crude to chemicals plants, specifically within China, just given that downstream demand for chemicals. So we certainly see that. We haven't seen as much demand on the side of biofuels and the pyrolysis application, but we certainly see it on the chemicals side. We see that as emerging, growing within China.
Another question. I've seen a few studies which concluded that biofuel production causes more environmental harm than that of gasoline. Do you think catalysts can close this gap enough to make biofuels viable, even in absence of incentive programs?
I'm not aware of that study, so I can't comment on that study. I would say that like all new technologies go through some curve on cost effectiveness, maximization of like the energy content versus the energy to create it. Again, we've gone through this also in our company on lithium, right? You look at it and like there's a carbon footprint to produce lithium that goes into an electric vehicle. And so what does that mean relative to the impact of the electric vehicle versus a traditional vehicle? And again, as like things become more and more efficient, as upstream becomes more and more effective in reducing carbon footprint, you start to see that downstream. So I think that whatever the carbon footprint is of biofuels today, of electric vehicles today, or even of traditional fuels today, all of those, given like the upstream efforts that are going on, I think all of those come down over time, because I think the value chain in each of those segments takes it very seriously. But I'm not familiar with the specific article.
Well, I think we are dead on time for a 2 o'clock conclusion. I really wanted to thank you for this very informative presentation and a very dynamic Q&A. And I appreciate it very much. Peter, anything you wanted to say?
Yeah, my last word is that, first of all, I hope all of you will attend a number of our events for the rest of the year. We have some very exciting topics. And for anyone who says that the chemical industry is not exciting, they obviously haven't listed presentations like the one that Raphael did. There's a lot of change going on, and a lot of the big picture changes that are going on, whether it's the price of oil or sustainability and so forth, are all having a big impact on the chemical industry and how it operates. So I want to encourage all of you to come to our events, either in person, we hope at some point. We do hope that we'll be able to restart some in-person events in October, but we hope to see you either virtually or in person at our events for the rest of the year. So thank you all. And again, thank you, Raphael, for that wonderful presentation and the answers to questions. And thank you, Federico, for arranging today's speaker.
Thank you very much.
Thanks, guys.